Hello dear students, welcome to EPG Pathshala. I am Dr. DC Saxena, Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am here to present the paper Technology of Spices and Condiments. In the present module, you will be knowing about the cryogenic grinding, its benefits, its advantages and limitations as one of the grinding methods in the case of spices and condiments. And this module will be explained to you by my co-author Mr. Narendra Kumar Chandla.
Hello students, welcome to EPG Pathshala. I am Narendra Kumar Chandla from Sant Longowal Institute of Engineering and Technology. Today, I am going to talk about module 33 of paper number 10, that is Technology of Spices and Condiments. In this module, we will be discussing about different types of grinding methods. Spices are an integral part of the Indian food. We all know it. With consumption not only in the households, restaurants, and even in the eateries, but they are utilized in the food industries, such as in preparation of the pickles, in the preparation of the sauces, instant curry powders, for the development of the ready-to-eat food preparations, and so on and so forth. Spices play an important role in enhancing the flavor and the taste of the processed foods in a better way when they are ground. These properties are enhanced by the process of grinding, which is an old age technique. Hence, a spice grinding unit operation is recommended. The main aim of the spice grinding is to obtain the smaller particle with a good quality product in terms of flavor and color. In the normal grinding process, heat is generated when energy is used to fracture a particle into a smaller size. This generated heat further detrimental to the product and results in a loss of flavoring and subsequently the total quality of the product. During grinding, the temperature of the product rises to a level in a range from 42 to 195 degrees centigrade, which varies with the oil and the moisture content of the spices. But spices lose a significant fraction of their volatile oil and flavoring compounds due to this rise in the temperature. The losses of the volatile oil for the different spices have been reported. After drying operation, grinding reduces the size of the solid materials by mechanical action, dividing them into smaller particles by unit operations, which are carried out by disintegrators and converted into powder by MicroPulverizers. I will talk about grinding, its methods and equipment used for the grinding. I will be discussing the grinding in detail and comparing the conventional grinding with the cryogenic grinding with its advantages. Here we also talk about grinding, size reduction techniques, grinders, hammer mills, micropulverizers, ball mill, pin mill and cryogenic grinders. Introduction. As we know, spices play an important role in enhancing the properties, especially the flavor and taste. These properties are enhanced by the process of grinding as an age-old technique like grinding of other food materials. During grinding, the temperature of the product rises to a level in a range of 42 to 95 degrees centigrade, which varies with oil and moisture. The loss of the volatile oil during grinding of caraway seeds have been reported to be 32%, with an increase in the grinding temperature ranges from 17 to 45 degree centigrade. Therefore, the increase in the temperature may result in loss in the volatile components. Cryogenic grinding and other grinding techniques which are imparted at low temperature have been developed to prevent the loss of the flavor. Grinding methods. In the grinding process, materials are reduced in size by fracturing them. Materials are fractured by various means. The mechanism of fracture is not fully understood, but in the process, the material is stressed by the action of mechanical moving parts in the grinding machine, and initially the stress is absorbed internally by the material as of the strain energy. Grinding is therefore achieved by mechanical stress followed by rupture, and the energy required depend upon the hardness or the solidness of the material, and also upon the tendency of the material to crack, its friability. Size reduction operations. As we know, size reduction is an important technique for conversion of material or composite material into a powder material. The product from an intermediate grinder might pass through a 40 mesh screen. Most of the product from a fine grinder would pass through a 200 mesh screen with a 74 micrometer of opening. An ultra-fine grinder accepts feed particles no longer than 6 mm. The product sizes typically vary from 1 to 50 micrometer. Cutters give particles of definite size and shape, ranges from 2 to 10 millimeter in length, but most of the times the material is passed through 200 mesh screen, so to have the powder. Grinders. As in the figure, we have shown the grinder, especially a stone plate grinder which have been used in the ancient time. Grinders. As far as grinders are concerned, they are used for the reduction of the size of the particles. The term grinder refers to a variety of size reduction machines for intermediate duty. That means they are not meant for the conversion of raw material into powder, but it could be in between that of the powder and raw material, and which we may know as the grits. Product from a crusher is often fed to a grinder for the further reduction. The grinder operation primarily consists of grinding mill and a pulverizer. Grinding mill reduce the sizes of the particles and pulverizer convert these particles into fine powders. Some of the commercial grinders which are used in spice grinding are hammer mills, impactors, rolling compression machines, attrition mills, ball mills, pin mills, and tumbling mills. These mills all contain a high-speed rotor turning inside a cylindrical casing. Here we will talk about the hammer mill operation. In this, shaft is rotated horizontal to that of the cylindrical casing. Feed dropped into the top of the casing is broken and falls out through a bottom opening. In a hammer mill, the particles are broken by the sets of swing hammers pinned to a rotor disc, and subsequently ground powder is obtained in bags. Hammer mill working. In this, you will be viewing inside the hammer mill and its cross-sectional view for better understanding. This image shows that how the coarse particle enters as a feed and gets out as final particle from the hammer mill. MicroPulverizer. As we know, micro means small, pulverizer means we have to pulverize something so to achieve powder particles. Pulverizer is a high-speed hammer and screen mill. In this, the particles or the commodity or the solid component is passed through the feed as a feed inside the pulverizer, and the grounded material is further passed through the screens, which accomplishes the separation of the granulated and powder material. Actually, in this process, high-speed hammer and screen mill are accomplishes size reduction by mechanical impacting. This method of size reduction is characterized by relative high energy and short residence time, minimizing the heat buildup during the milling process. MicroPulverizer. As we have discussed, the feeding material to be crushed enters the mill through a gravity feed hopper having an adjustable side to control the feed material. That means the feed material flow rate could be controlled. The material is crushed between the hammers or through the blades and serrated liners. The ground material is continuously sucked by a powerful blower through a screen classifier and conveyed through the pipe into a cyclone drum for the bagging purposes. The blower maintains constant airflow in the grinding chamber in order to obtain a product and continuously cleans the screen. If the screens are not continuously cleansed, then there may be the possibility of backing and results less reduction in the particle sizes and less perforation through the screens. Particle size of the ground material can be varied over a large range by using sieves with a desired opening. the sieves size or the opening size vary depending upon the final product. Operating principle of a pulverizer. The feeding material to be crushed, first it enters the mill through a gravity feed hopper, having an adjustment in terms of the slide to control the feed material. The material is crushed between the hammers and the blade and the serrated liners. The ground material is continuously sucked by the powerful blower through a screen classifier. As we know, screen classifier, they suck it through the screens and conveyed this through the pipe into a cyclone drum for the bagging purposes. The blower maintains constant airflow in the grinding chamber so as to maintain a product and continuously cleans the screen. Particle size of the ground material can be varied over a large range by using sieves with a desired opening. MiniPulverizer. MiniPulverizer consists of a heavy-duty mild steel or stainless steel body, which comprises of a feeding hopper with the feed regulator slide. The pulverizer body is inlet with the delivery trough attached at the bottom, with the delivery trough attached at the discharge end. The rotor and the beater are mounted on shaft, which run in ball bearing housing at a speed of 4,500 to 6,000 RPM. The whole unit is mounted on a strong steel channel stand. MiniPulverizer. Applications. MiniPulverizer is widely used for grinding of dry or wet spices, specifically green chili, fresh ginger, garlic, fresh fruits and vegetables. These machines can also be used as a fruit finisher. The MiniPulverizer can also be used for the following dry applications like agricultural chemicals, broken biscuits, custard, powder coffees, charcoals, dal, dyes and pigments, and could be used for the fillers, henna leaves, herbs, other leaves and roots for instant foods. It can be used as an insecticide, pesticides, kaolin, molding powders, pharmaceuticals, plastics, poultry feed, marine feed, resins, sugar, tea, etc. for the powder formations. Ball mill. A mill of this kind contains balls of different sizes, all of which bear and become smaller as mill is operated. New large balls are added periodically. As the shell of the such mill rotates, the large balls moves towards the point of the maximum diameter and the small balls migrate towards the discharge. The initial breaking of the feed particles is done by largest ball dropping the greatest distance. Small particles are ground by small balls dropping a much smaller distance. The amount of energy expended is suited to the difficulty of breaking operation, increasing the efficiency of the mill. In a ball mill or the pebble mill, most of the reduction is done by impact, as the balls drop from near the top of the shell. Cylindrical ball mill. As have been shown in the figure, when the mill is rotated, the balls are picked up by the mill wall and carried nearly to the top, where they break contact with the wall and fall to the bottom to be picked up again. Centrifugal force keeps the balls in contact with the wall and with one another during the upward movement. While in contact with the wall, the balls do some grinding by slipping or rolling over one another as discussed. But most of the grinding occurs at the zone of impact, where free falling balls strike the bottom of the mill. Pin mill. Pin mill is a high-speed impact grinding machine designed for the grinding of dry materials by the application of pins, which are fitted onto the rotor and stator part of the mill as shown in the figure. The grinding action within the pin mill is achieved by impacting the product particles with a series of hardened steel pins by means of relative motion between movable and fixed head of pins. The material is crushed by the impact and friction of the teeth and the impact among the material. Pin mill as a pictorial overview. As have been shown in the figure, the feed material is fed into the center of the rotor having pins and is conveyed to the periphery through series of plates, therefore gradually reducing to the final powder. Screen drum fitted around rotor permits ground material of desired fineness to come out of the mill for the collection. In this, we will be learning about the complete detail of 3D view of the mechanism of the operation of pin mill. Cryogenic grinding process. Earlier, we have discussed various grinding techniques and we have discussed the methods through which we can convert the solids or the raw material into powders. But these techniques were the conventional methods which can have an disadvantage of generating heat. Therefore, cryogenic grinding need to be discussed. In cryogenic freezing or cryogenic grinding, generally it consists of pre-cooler and a grinder with the cryogen distribution system. In such grinding systems, cryogens subject the raw material, that is the spice, up to or lower than the glass transition temperature before it is ground, thus eliminating much of the material and quality hassles of the traditional grinding. At present, the capital investment including cryogen and handling cost, which escalate the final cost of the product. This is a new concept in the spice processing, which results into high production with better and product quality in terms of aroma and color, in comparison to that of the conventional spices grinding units. Cryogenic grinding finds pivotal applications in food, that is spices, and in condiments. Process description for this process is the feed is introduced in the granular form as a spice and liquid nitrogen sprayed onto the product, which was later conveyed to hammer in grinder at a temperature of 195.6 degree centigrade through a screw conveyor. The product is disintegrated, screened and filled into bags by the method of gravitation. The liquid nitrogen used is further recollected through a refrigeration system for the process economy of the product formed. Working range of cryogens to be produced the desired low temperature, and generally liquid nitrogen is extensively used in the food grinding purposes, especially in case of spices where flavor, aroma and volatile components are of great interest. Application of low temperature shows a promising pathway to produce higher quality end product with higher flavor and volatile oil retention. This is a new concept in spice processing which results into higher production with better end product quality in terms of aroma and color in comparison to that of the conventional grinding of the spices. Cryogenic grinding advantages. As we have discussed, conventional grinding may have some disadvantages in terms of the heat generated during the grinding. Therefore, the cryogenic grinding have the edge over the conventional grinding in terms of various advantages. The advantages offered by this spices grinding technology as against of conventional spices grinding technology are as under. This grinding technology improves the aroma by minimizing the loss of the essential oil, approximately 3% loss. Number 2, spices processed using liquid nitrogen for grinding has better natural color as compared to the conventional process. Third advantage is finer particle size can be achieved without loss of aroma and natural color of the product. Fourth is overall grinding capacity can be increased by 2 to 3 times as process equipments will not have thermal fatigue due to heating up of the machinery. Fifth is this method of grinding enhances unlocking of natural flavors which aid easy dispersion of the same and control flavor strength. Mechanism of action. The fat content of the spices possess problems of temperature rise and sieve clogging during grinding. Due to this temperature rise, spices lose a significant fraction of their volatile oil or flavoring components. A cryogenic grinding system was designed and developed to cool the spices before feeding to the grinder and also maintain the cryogenic temperature in the grinding zone. The main components of the cryogenic grinding system are a pre-cooler and grinder as discussed. The pre-cooler consists of a screw conveyor assembly, a compressor, a liquid nitrogen and a power transmission unit. The increase in the grinding temperature from 160 to 170 degrees centigrade results in a significant increase in the particle size of a product and specific energy consumption in the grinding. The loss of the volatile oil can be significantly reduced by a cryogenic grinding technique. Summary: the main aim of spice grinding is to obtain smaller particle size with good product quality in terms of flavoring and color. The size reduction is done by the application of hammer mill, ball mill and stone mill, and by the commercial grinders along with the pulverizers. They all can be applied individually or could be in combination with one another. In the normal grinding process, heat is generated when energy is used to fracture a particle into a smaller size. This generated heat usually is detrimental to the product and results in some loss of flavoring, color and overall quality of the product. The loss of the flavor can be prevented by application of cryogenic grinding or the grinding at lower temperatures. Cryogenic grinding is done at very low temperature as liquid nitrogen as a carrier gas used at a temperature of minus 195.6 degrees centigrade to provide the refrigeration conditions so as to pre-cool the spices before grinding and maintain the desired low temperature by absorbing the heat generated during the grinding operation. Cryogenic technology of grinding spices offers a number of advantages as against conventional spices grinding technology. For example, improves the aroma, incremental natural color, finer particle size and overall grinding capacity could be enhanced or increased by 2 to 3 times by the cryogenic. So students, let us now summarize what we have learned in this module. As we know, the grinding is the unit operation which decided the quality of the spices in terms of their essential oils and the aroma and flavor present inside them. The main aim of the spice grinding is to reduce the particle size so that it could release intracellular components and subsequently results good product in terms of enhanced flavor and the color. Spices play an important role in enhancing the flavor, taste and color of the processed foods in better way when they are ground. These properties are further enhanced by the process of grinding by various size reduction techniques as we have discussed, like hammer mill, ball mill, pen mill and pulverizers. As we know, in grinding process, heat is generated and results loss of the flavoring and quality in terms of the loss in the volatile oil and flavoring components which are lost at higher temperatures. Therefore, cryogenic freezing and cryogenic grinders recently being introduced for the grinding of the spices which are more susceptible to the volatile losses. In such grinding systems, cryogen subject the raw material up to or lower than glass transition temperature before it is ground. Therefore, eliminating much of the material and the quality hassles of the traditional grinding. That is all about the grinding methods of the spices. Thank you.
You have the knowledge of cryogenic grinding as one of the grinding methods which has been explained to you in the present module. Now, the most important parameter in the case of spices and condiments is the quality of spices, and quality of spices is depend upon the grinding of spices, and this aspect will be explained to you in the next module. Thank you.